So welcome back to my channel. Today we are going to explain about the shortest job first in its non-preemptive method. Shortest job first is going to be a scheduling algorithm, which is one of the four algorithms which I use. The other four are basically the priority, the round robin, and the first come first serve, and shortest job first. And there are many more. If there are many more. But then we are going to consider five processes today in our video. What is non-preemptive? That's the main question. What is non-preemptive? Non-preemptive means that when a process is being executed by the CPU, it will be continuously executed until it's terminated. So that's what non-preemptive means. But preemptive means that when a process is in the CPU, it will have context switching again and again and again for the CPU to work in a good way. But now this is non-preemptive, which means that the process will be continuously executed until terminated. So that's what this explains. Shortest job first. Now we are going to explain what and how to take the average waiting time using a simplified method. So I'm going to first do something like this. I'm going to take the mark and now I draw this thing that we are going to get the processes. So P1, P2, P3 and P4 and P5. Now this is shortest job first. This is somewhat very similar to the first come first serve, but this is not first come first serve. This is shortest job first. Now this is what you are going to get confused with. You tend to take arrival time, then burst time, arrival time, burst time, but no. Shortest job first is going to be considered on in a way like this. So first of all, you got to consider process 1, which comes at time 0. So therefore it comes at time 0. P1 is going to be 8. It comes in the time 0. So now that 8 is done, you can see that at this time 8, all these processes have come inside to be executed. So what are you going to take from this? What you're going to take from this is that you're going to take the shortest burst time, because this is the shortest job first. Shortest burst time is consisted in P2. Let's say P2 has a burst time of 4, which is 8 plus 4 is 12. So therefore, you can take P3. Can you take P3? No. P3 has the most burst time of these three processes. All these processes have already come because we explained that before. P3, P4, P5, what are you going to choose from this? You're going to choose the least time. It's 5. Let's take P4. P4 is 12 plus 5 is 17. Now that's done. Let's take P4, let's take P3 and P5. What are you going to take? P5, shortest job first. P5 is going to be 23. Now P5. Now you have the rest P3 and now you just put it P3. Total is 32. Total is 32. 8 plus 4 is going to be 12. 12 plus 9 is going to be 12 plus 9 is going to be 21, I guess, right? 21 and 30, 11, 32. So burst time and this time is both the same. So therefore you can verify that your answer is correct. There's nothing to worry about your answer from this point on. If the total of burst time is equal to this number at the end of the queue. So now how are you going to find the waiting time and response time? You first got to consider some other time intervals, things like this. So now I'm going to mark them. We have burst time, and now what do we have next? After burst time, we have something called the completion time. After the completion time, we have something called the turnaround time. I will draw it, I'll write it in a way that you can see it well. Completion time, turnaround time, waiting time, response time. So what is turnaround time? Turnaround time is total time taken by a process from the beginning until its time of execution or its termination. Waiting time is the time taken by a process in the ready queue. Response time is the total time taken by a process to commence. Those are the definitions of these three. So completion time is when P1 gets complete. It's 8 here. Therefore we put 8. And now we have P2. P2 is being completed at 12. P4 is being completed at 17. P3 is going to be completed at 32. P5 is going to be completed at 23. So we have always done. Now we are going to mark the rest. Arrival time, a turnaround time is found by subtracting completion time by arrival time. This is how you get. So 8 minus 0 is 8, 12 minus 1 is 11, 32 minus 2 is 30, 17 minus 3 is 14, 23 minus 4 is 19. So waiting time, how are you going to take waiting time? This is how. Waiting time is coming like this. Turnaround time minus burst time. So you have 0 here. 11 minus 4 is going to be 7. 30 minus 9 is going to be 21. 14 minus 5 is going to be 9. 19 minus 6 is going to be 13. So, response time is found like this. Response of P1 is starting at 0. 0 minus 0 is 0. P2 is starting like this. 8 minus 1 is 7. P3 starts at 23. 23 minus 2 is 21. P4 starts at 12. 12 minus 3 is 9. P5 starts at 17. 17 minus 4 is going to be 13. So now you can see a pattern in waiting time and response time that they are both the same. Now this is true only for non-preemptive, and for only for non-preemptive in any algorithm, the waiting time and response time will surely be the same. So now the question asks that we should take the average of waiting time and response time. Whatever you take, it's basically the same, but we are going to take the average of response time. 0. So 0, 7, 21, 9, 13. So 7 plus 13 is going to be 20, is going to be 30. So 50 is total average response time. Is equals to 10 milliseconds. Now this is the basic answer that you are bound to find in this question. So I hope you made use of this video, and I hope that you understood all of the processes which I have done. And if you have any problems, you can comment it down on the comment comment line down below, or you can like, you can subscribe and share this video. Thank you.